Welcome back. This is the homework video for Chapter 2, Section 1. As you can see on the screen, here are the assignments that I have assigned. Here are the problems that I'm actually going to do. Now, I recognize that there are only 3 problems that I'm going to do, even though there are 5 different sections. The reason for that is because those sections are very specific, so you need to go back and watch the lecture video if you have homework questions on the other sections. All right, problem number 3 says identify the domain and range of the given relation, then represent the relation using a graph or a mapping diagram. So I'm actually going to do this problem 2 different ways. I'm going to identify the domain and range, and then I'm going to graph the points, and I'm going to use a mapping diagram. But remember, you only have to do one, either the graph or the map. You do not need to do both. So we're going to start off with domain and range. As was explained in the lecture video, domain pertains to the x variable. So we need to know which one is our x. So again, our values come to us as ordered pairs. Well, why are they ordered? They're ordered in x, y. So every one of our points here is going to be an x and a y. Okay, an x and a y, all the way through. So when I say domain, all I really want you to do, so I just want you to really list the x values. But when you do, we do not need to worry about repeats, but we do want to list the domain in order from smallest to biggest. So I'm going to use a curly bracket here, and what that identifies to the reader is that we are in fact talking about a set of numbers. So that's domain. It's a set of all the numbers we have. We're just focusing on these few. And what is my smallest x? Right, -4, and then -2, 1, and then 3. Whoops. So a -4, -2, 1, and then 3. And again, we will end with a curly bracket. Okay, range starts off the same way. Except if domain pertained to x values, what do you think range pertains to? Right, it pertains to the y's. So again, we're going to list them in ascending order, and we do not worry about repeats. So we're going to go -3, -1, 2, 3. That is your domain and range. Done. Okay, now I'm going to do the mapping technique. So for a map, you're going to have 2 boxes, an input box and an output box. So this is a domain. This is a range. Okay, input, output, x, y. All of those names mean the exact same thing. So we're going to list our values. So our x values are -4, -2, 1, and 3. Our y values are -3, -1, 2, and 3. And when you map, what you do is you're going to use arrows to connect the appropriate pieces. So -4 out of our domain. So if we look up here, -4 maps to a -3. So those two go together. So I signify that with an arrow. -2, which is our next x, maps to +3. So I use an arrow and draw a line from -2 on the input to 3 on the output. And then I just keep working through. So at 1, for my input, I'm at 2 for an output. And at 3 on the input, I'm at -1 on the output. And that's your map. Nice and easy, okay? Now, when it comes to graphing them, they actually want you to graph it on an axis. Okay, so let me bring over our points. So we're going to draw the x-axis here, and then we're going to draw the y-axis. And we're going to find these points on here. So our first point is -2, 3. And again, remember, the values always come to you in order. They're an x and then a y. So our first x value is -2. So we start at 0 on the axis, which is the origin, but it's also where the 2 axes are going to crisscross. So we're at 0, 0. And we need to get to -2, 3. So -2 is our first move. So the x-axis, is that the horizontal or is that the vertical? Right, it's the horizontal. So we're going to label it as an x. And that means that our first move is going to be on the x. So I need to move to -2. So horizontally speaking, is -2 a move to the left or to the right? Correct, it's a move to the left. So we're going to go 1, 2 units to the left. So I'm sitting right here. Now I need to move in the y direction. Our y value is 3, so are we going to move up or down? Right, we're going to move up. 1, 2, 3. And this is our point. And that's it. We don't need to label it because they didn't give us any labels. You can label it if you want to, but you don't have to. So remember, whenever you move on a Cartesian coordinate, you're always going to move left to right first, and then you're going to move up and down. Okay, so our next point, x equals 1, so we're going to go over 1, and then y is 2. So again, is that up or down? Right, that's up. So we're going to go up 2. And we keep working. So for our next value, 3, -1. Start at the origin, okay, move 3 units to the right, and then move down 1 because my y is a negative. -4, -3. Again, go back to the origin to start. That's why it's called the origin. It's where everything originates from. And then we move 4 units in a negative direction, which for the x is to the left. So I'm out here. And then I move -3 in the y, which is down 3. And this is where my point's at. Okay, so again, it doesn't matter whether you use a mapping system like this, right here, or if you use a full graph like this. You do need to include the domain and range, and then one other way of representing our points, and that's all you really need to find. Okay, problem number 16. Tell whether the relation is a function. Explain your answer. Okay, so this entire time, if you've listened to the lecture video, you've listened to me talk over and over again about things being one-to-one. And what that means is that for every x we have, we get exactly 1 y. Okay, so remember, our x's are in the lead, so I want to look at these values. Okay, look at the first position. Do I have any repeated numbers? Now, I know you're kind of sitting there going, but we've got a 2 and a -2. Right, but are they exactly the same? No, they're not. So are they the same number? No, they're not. So take a look at the circled values here. We've got a 3, a 0, a 1, a -2, and a 2. So when you take a look, do we have any repeats? No, we don't. And what that means is that this relation is, in fact, a function. So yes, this relation is a function. Now, how do I know it's a function? Because for every input, how many outputs do we get? Right, we have exactly 1, right? Do we have any repeats in the input? No, we have different inputs all along the way. So what that means is that this relation is 1-to-1, which is our definition for a function. Okay, so yes, this relation is a function because it is 1-to-1. Okay, and again, what that phrase means is that, change that to a comma. So what that phrase means, 1-to-1, is for every input, we get exactly 1 output. So what we want to do is look at our x's and see if we have any repeats along the way. Here, we do not have any repeats, so it is a function. All right, 33, graph the equation. Now, if you notice, I have this set up to where I'm going to use an XY chart. Okay, whenever you graph something, if you don't know how to graph it, just go back to your XY chart, okay, your 5 values. So what are the 5 values that we always use when we graph? Right, -2, -1, 0, 1, 2. Is it kind of boring? A little bit, but is it guaranteed to get you the right answer? Absolutely. So it might be boring, but make sure that you know how to do it, so that way you can get the job done regardless of what you're looking at. All right, so let me make my x and y axis here. And again, we're going to label these. Okay, so which one is the horizontal? Right, that's the x. And the vertical is going to be our y. All right, so now what we need to do is plug these values for x into the equation. So I'm going to work the first one all the way out, so that way you can see what's going on. And then we're going to just kind of cook through these, okay? So this is what we have. -3/4 times -2, because that is our x value, and then minus 1. So first of all, what's a negative times a negative? Right, that's going to be a positive, so we can actually not worry about the signs. Multiply the top together, so 3 times 2, which gets us a 6. 4 times 1 gets us 4. And then we still have that minus 1. Minus 1. Okay, now 6 over 4, we should know, reduces to 3 over 2. 1 is the same thing as 2 over 2. So what's 3 halves? Take away 2 halves. Right, that's going to leave us with 1 half. So that is the value for the y given x equals negative 2. So all you're going to do is take this x value and substitute it back into the equation for x and use your order of operations to get the answer to a single value. And that's all they really want you to do. So here if I plug in a negative 1, negative 3/4 times negative 1 is going to be a positive 3/4. Take away 1 is going to leave us with a negative 1/4. Okay, plug in a 0. 0 times anything is 0. 0 minus 1 is negative 1. 1 times negative 3/4 is negative 3/4. Take away 1 whole, that's going to be negative 1 3/4, or 7/4. Now, the last one, we're going to do the exact same way. So take our 2. Negative times a positive is negative. 3 times 2 is 6 over 4. That's 3 halves. Negative 3 halves, sorry. Minus 1 is going to become a negative 5 halves, or a negative 2.5. Again, you can either use the decimal representation, like we did here with negative 2.5. You can use the improper fraction form, which is the 7 over 4, or you can even use the mixed number form, which is the negative 1 3/4. It does not matter which method you use as long as you are accurate, and if you leave things as an improper fraction, it is reduced all the way down. So now we can plot our points. So at negative 2 on the x, we're at positive 1/2. At negative 1, we're at negative 1/4, which is right about here. At 0, we're at negative 1. At positive 1, I'm at negative 1 3/4, which is right around there. And at 2, I'm at negative 2.5. 2.5. Now, if I did this right, when I grab my ruler here, I should be able to set up my ruler and pass through pretty much all of the points. I should pass through all of them, but remember, with fractions, it gets a little dicey because you're kind of guessing where is a half, where is a quarter. But with the halves and quarters, you should be able to get pretty accurate, okay? This is why we have graph paper available for you. And there's your line. And just like that, you're done. So whenever they ask you to graph the equation, make an XY chart with your 5 x values that we always use, because it usually paints us a very good picture. Plot the 5 points as XY pairs. So this is your X here on the left. This is your Y on the right. Work all the way through and plot all 5 of your values. And then connect them with the line, and you should have a straight line that passes through all 5 values. Okay? So like I said before, if you still have questions on the homework, make sure that you watch the lecture video, and if that still doesn't answer what you're looking for, make sure that you ask in class. Again, here's your homework assignment. As always, these problems are complements of the Algebra 2 Michigan edition, distributed by McDougal Littell.